All right, here we go. This is the 2015 BC International Exam, question number 2. It's calculator active, and let's get going. The figure above shows the graph of the polar equation r equals 2 plus sine 4 theta plus cosine of theta for the interval 0 less than or equal to theta less than or equal to pi over 2. The derivative of r with respect to theta is given by r prime of theta equals 4 cosine 4 theta minus sine theta. Okay? In part A, we're asked to find the area of the region bounded by the graph of r and the lines theta equals 0 and theta equals pi over 2. Now, I know that we've all studied polar, and in polar, the area of a bounded region is going to be the integral of your radius squared with respect to theta from your starting angle to your ending angle. Now let's take a look at this. They're saying from the line theta equals 0. Now in polar, the angle is going to be 0. So we're talking about this being the line theta equals 0. All the way until we get to an angle of pi over 2. That's going to be this guy up here. Theta equals pi over 2. And the radius expression that we have here is going to determine the value of the radius as we move from theta equals 0 around to theta equals pi over 2. So all I have to do is find the integral from 0 to pi over 2, and then take your radius expression, 2 plus sine 4 theta plus cosine of theta, the whole thing squared, with respect to theta. Let's go to the graphing calculator. Now, because I have looked at this question already and I know that there's going to be some more stuff coming up, what I'm going to do is I'm going to go over and I'm going to graph the polar equation, but I'm going to graph it in rectangular form. And part of that is because the graphing calculator, although it will allow you to graph polar equations, well, number one, we don't need a graph because they already gave us a graph. Secondly, you're going to find that the graphing calculator does not allow you to do some of the nice things that you might like in polar. So instead, I usually just graph in rectangular form. And I'm wondering where my graph is. It should be showing up. Let's see, menu, settings. Let's make sure I'm in radian mode. Okay, good, that's what I want. Let's make sure that I actually type that equation in. Look at that. F1 equals 2 equals. That's the problem. So 2 plus sine 4x plus cosine of x. Let me change my window back to the standard viewing window that I had originally. Now, this is obviously not the graph that they gave us. This is what the graph of f1 equals 2 plus sine 4x plus cosine of x looks like in rectangular. In terms of my computations, though, I'm going to go on over, and we're going to do, we need 1/2 times menu, go to calculus, numerical integral. We're integrating from 0 to pi divided by 2. And it's that function that I just typed in, squared, integrating with respect to x. And if all goes well, your answer is going to be 6.194. Let's go back to the screen here. And there we go, 6.194. The integrand, which is this 2 plus sine 4 theta plus cosine theta squared, was worth 1 point. Being able to find that value on the calculator earned you the 2nd point. Not too bad. Really, you just need to make sure that when it comes to polar, you know the integration formula for area. 1/2 the integral of the radius squared with respect to theta from your starting angle to your final angle. Let's take a look at part B, see what's going on there. In part B, now they're asking us to find the area of the region that's in the first quadrant that is outside the graph r equals 2 plus sine 4 theta plus cosine theta but inside the graph of the circle of radius 2 centered at the origin. Now, let's think. We've got the origin. My radius of the circle that we're looking at has a radius of 2, so I get to go out 2 in each direction, and I'm going to make, well, because we're in the first quadrant, just the quarter circle. They're asking me to find the area that is inside r equals 2, but outside this other curve. Inside r equals 2, but outside the other curve, that's this region in here. What's going to make this problem a little bit difficult for us is we need to figure out the starting angle. The starting angle, this guy right here, so let's call that alpha, is going to be whatever angle causes these two curves to intersect. Let me try writing that out. We've got in part B the curve r equals 2, and we've got r equals 2 plus sine 4 theta plus cosine of theta. And I know that the intersection happens somewhere between theta equals 0 and theta equals pi over 2. What I'm going to do is go back to the calculator. And we have the graph of the equation 2 plus sine 4x plus cosine of x. To this, I'm going to add another function. So let me do tab 2. This is that second function. This is the circle of radius 2. And what I need is I need the intersection point between these two curves that happens between 0 and pi over 2. Let me change my window here. Maybe this will make life a little bit easier for us. We're going to go from 0 to pi divided by 2. So now I'm only looking at x coordinates between 0 and pi over 2. I'm looking for the intersection point between these two curves. I can see it happens right here. So we're going to go to Menu, Analyze Graph, Intersection, a little to the left, a little to the right, and I'm getting that this happens. The intersection is at theta is approximately 0.942. All right, I know because of what we're going to do next that we need this value, so I'm going to go over to var, 0.942. I'm going to click on it once, var, store var, and save it as something. I'm going to call it A. Okay, so where are we? Let's go back. These two curves, the intersection is at 0.942, which is A. That's this angle here. The angle that I'm looking at is angle A. In order for me to find the area bounded by these two curves, I'm going to look at the area that's bounded by r equals 2. So that's going to be 1/2 the integral from my starting angle, which is A, to my final angle, pi over 2. My radius there is 2 squared, d theta. But that would give me the area for this whole little pi section here. I need to subtract out the part that is below the other curve, so minus 1/2 the integral. Starting angle is A, upper angle is pi over 2, and it is going to be this 2 plus sine 4 theta plus cosine of theta squared d theta. That's the expression that I need to evaluate. So we're going to go back to the graphing calculator, and let's see what we get. Back to the graphing calculator, back on the calculate screen. I've already got this expression in there once, so let me pull that down. We need 1/2 the integral of 2 squared, but we've got to be careful. We're integrating from A to pi over 2, and then minus 1/2, menu, numeric calculus, numerical integral from A to pi over 2 again. Now this 2 plus sine 4 theta plus cosine theta, That's what we've got stored as our function f1. So we're going to square that, and we're going to integrate with respect to x. And if all goes well, we get 0.456. That is the area we're looking for. Perfect. Let's go back and let's see where the points are coming from here. So this is a 4-point problem. College Board awarded the first point for finding the correct value of the angle where the curves intersect. The integrand, you could have done it as one, because the limits of integration are the same. We're going from a to pi over 2. You've got the same multiplicative constant of a half. You could have done this as one integral. I chose to do it as 2. So they offered 2 points for the integrands, meaning this part here and this part here, and then 1 point for the final answer. So this is a 4-point question. And although it's pretty tricky, it's not that far out of what we should be able to do at this point in the course. Okay, let's move on to part C. In part C, we're asked to find the value of theta in the interval 0 less than or equal to theta, less than or equal to pi over 2, that corresponds to the point on the curve where r equals 2 plus sine 4 theta plus cosine theta has the greatest distance from the origin. Okay, let's stop and think for a second here. We're in polar. We're asking about greatest distance from the origin. Well, here's the origin, and we're looking at the distance from the origin out to the curve. And so what you're looking at is I'm looking at all these little line segments that connect the origin onto the curve r. And this r is the 2 plus sine 4 theta plus cosine theta. Well, how do I find that distance? That distance is just what the value of r is. So in part C, I need the maximum value for r equals 2 plus sine of 4 theta plus cosine of theta on the interval 0 less than or equal to theta less than or equal to pi over 2. What I'm hoping is that if you're watching this video, you know when we look for a maximum, what we're really looking for is an absolute maximum. Our process for doing this is you look for the relative maximum. This is your candidate. The relative maximum is where r prime, the derivative, changes from positive to negative. So what we need to do is we need to look and see where is it that r prime, which we know is 4 cosine of 4 theta minus sine of theta, where's that equal to 0? Well, let's do that. Let's go ahead and let's graph that function. So back to the calculator. And we're going to go on over to the graph screen. Okay, I'm going to put in a new function. And this one is 4 times cosine of 4x minus sine of x. And while I'm here, because I've got so many functions going on, I'm not interested in looking at f2. I'm not interested in looking at f1. I'm not interested in looking at f1. I just want to look at f3. This is the derivative graph. I'm looking for where the derivative changes from positive to negative, meaning from above the x-axis to the below the x-axis. And we can see it's going to happen over here. So menu, analyze graph, 0, little to the left, little to the right. This is happening at 0.370, so I'm going to write this down. Theta is approximately 0.370. And because we're going to need this for some calculations, let's store it. So that was single click to highlight, var, store var, call it B. Shows up in bold, so I know that I'm doing this correctly. Let's go back to the paper. We've got the value of theta. We're working on the intervals 0 to pi over 2. What are we trying to maximize? We're trying to maximize the distance, which is the radius. What I'm going to do is I'm going to make a table of values. Here's the angle, here's the radius. The angle options are 0, pi over 2, and 0.370 that we're calling b. We need to evaluate the radius at each of these 3 points. Now this is where we're going to go back to the graphing calculator. The original radius was stored as f1, so I need f1 of 0, and there I get a radius of 3. We need to evaluate the radius at the other endpoint, pi over 2, and we get 2. And then finally, we need to evaluate the radius at B. B was that intersection point, the point 370, and we get 3.928. Those are the 3 values. Let's go back to the paper. The question says, find the value of theta that corresponds to the point on the curve with the greatest distance. So I'd say distance from the origin is greatest. Is greatest at theta is approximately 0.370, and that's it. If they asked what is that greatest distance is 3.928. Now this was a 3-point question. The first point came from finding that candidate, the 0.370. The second point comes in from doing all of this analysis. In fact, this is where 2 points come in. They said they're offering 2 points for your answer with justification. Well, here's my answer. But my answer, if I don't actually stop and consider the value of the radius at the endpoints and the candidate, isn't going to work for me. So you've got to evaluate the radius at each of those points. Now that I've got those values, I know that the distance is greatest at 0.370. And that's it. Part C is worth 3 points. And my friends, that's it. Nice job. Good luck studying for the exam.